Hello everyone, in this video we will look at the audio signals. So in the last video we have seen that sounds are the waveforms and these waveforms are the signals which are given like this. So these signals are mostly these signals are analog signals. Sound in real is actually an analog signal. So you can say that sound in real is an analog signal. And we want to store this signal in our digital machine, which is you can say a laptop or a personal computer, whatever it is. So in order to store this signal into the digital device, we have to do certain conversions. And what are these conversions? So we want to convert the analog signal to the digital signal. And how to do it? This is the question for today's lecture. Why we want to convert this analog signal to digital signal? Because see here, this is a signal. Now this signal has a time duration. Let's say I take this interval. In between this interval, now this interval is continuous. So in between this interval there are infinite points. And due to these infinite points, if I store the infinite points, I will require infinite memory, which is not possible in digital devices. So because I have a limited memory, so I need to convert the analog signals to the digital signals before I process them. So to convert an analog signal to a digital signal, we have to do two things. One is sampling and another one is quantization. So let's look at them one by one. First of all, we look at sampling. Let's say you have this signal. In which the x-axis is time and the y-axis is x of t, which is the amplitude values. And now you have to discretize x-axis. You have to discretize x-axis. So how can we do that? Let's say I take samples. This is one of the sample, this is another sample, this is another sample, this is another sample, and I take a few samples, and these samples are taken at a equal distance, which is t. So I am saying that the time axis was t and I have taken n number of sample with equidistance t, which is given with equal distance between these samples, which is given by t. So now we have to understand that from the signals and system there is a theory which is the Nyquist criteria. And this Nyquist criteria says that if I give you these samples which I have taken here, the associated values of y-axis, which is x of t, at these samples. Then in order to recover this analog signal from these samples, it is very important that you set the Nyquist frequency should be half of the sampling frequency, which is like you have to take the sampling frequency as twice the maximum frequency present in the signal. And what is the sampling frequency? Sampling frequency is basically the inverse of the sampling time, which is the time period that you have taken between these samples. So it is like t is equal to n of ts. So you have to follow this criteria in order to recover this signal correctly. And if you don't follow this criteria, then the samples that you will store will not give you this signal when you will try to recover back. So this is an important thing that you have to follow when you do the sampling. This is one of the conditions that you have to follow. So whenever you will record a signal or you will see some audio signal, you will see that there is an associated sampling frequency to that signal, which is the number of samples in 1 second, which is like a vector of numbers, like how many numbers do you need in 1 second for this signal. Okay, so this is the concept of the sampling frequency, and it's very easy. For now we are not going much into the details of Nyquist criteria, but this is the simple definition of the Nyquist criteria. And if you want to see more about Nyquist criteria, you can follow my videos related to signal and systems, which will be coming in next few days. So let's go to the next thing, which is quantization. So we have this signal, which is the same signal. We have time axis, and we have the y-axis, which is x of t, the amplitude values. Now previously we have discretized x-axis, now we will discretize y-axis. And what does it mean? It means that I take a finite values, finite intervals at the y-axis, like this. Let's say this is 1, 2, 3, 4, 5, 6, 7 and 8. Let's say I take 8 values, which are the 8 intervals, and I have to sample this signal at these values. Now we take a finite set of discrete values, and these finite set of discrete values are called quantization levels. Now let's say I have some value here. What will I do? We will round off the continuous value to the closest discrete level. Here the closest discrete level is this one. So I will round off this value to this level, and because of this round off there will be an error. This error is known as quantization error. And how can we reduce this error? If we take more and more quantization levels, then this error will be minimum. Okay, but there is another thing that we have to look at. And what is that other thing? That other thing is more distinct levels of quantization requires more bits, and more bits will take more memory, because let's say you have 3 bits, so this means that you can take in total 8 levels, 8 quantization levels. So this is an important thing that you have to remember. So the number of bits per second is very important, which is also said as bit depth. So let's see an example. We want to calculate the memory required for storing 1 minute of the sound, and it depends on two things. One is the sampling frequency, another one is the bit depth. And how can we calculate this? You multiply the sampling frequency with the bit depth, and then this is now in bits per second, and I divide this number with this number. I divide the bits per second with this number, which is this one, and after this now this is in megabits per second. Now if I divide this with 8, then this all is in megabyte per second. Okay, now if I multiply these all with 60, which is the 60 seconds, so I will say that I have got the memory required to store 1 minute of sound. So you can see that if the number of bits are more, or the samples on the x-axis are more, then the memory required will be more and more. So now in this video we have seen two things. One is the sampling, another one is quantization. So whenever we will record our sound, we need, because the sound will be in analog domain, and to store this sound in digital system, we have to decide what is the sampling frequency, what is the number of bits which are required, and then there is another thing which is channel. For the moment we are not discussing this, but these are most important things that we have discussed for now. And now I think we are able to move to the MATLAB and do the first task, which is we will record our audio in the MATLAB, record the audio in MATLAB, in which we will use all these concepts we have studied till now, and then after that we will also take the Fourier transform in the MATLAB. I have not discussed the Fourier transform till now here in detail, but you can see this Fourier transform in my coming lectures of SNS, in which I will discuss this in a very detail, and you will be able to understand how the things are working. Thank you very much for this, and see you in the next video.